I'll send you another one. I know what we're talking about. We're talking about who
It's like all me all the time. Like how many? Like how many? Are we recording? We're recording. That's great. That's going to be on the recording.
Oh, I figured out who it was. I'm pretty sure. Let me double check. I'm not gonna say this wrong here.
Now I know I need to move that and then I can find the present button.
Yeah, I figured out who it was.
Lena did.
She did 4 though. She just did 34.
Oh, she did 34 now. All right. Well, you know, we figured it out. All right. So Sophie, are we good?
Yeah, I can hear you.
Hey, they do jumping jacks. Like I don't know what that's about. We'll move that up there. All right. So we're talking about families. Okay. You're going to need to label this next family. The next family is group 2. So
Alkaline earth.
their families, their groups. The next group is
Alkaline earth.
There's my mouse. There's my mouse. Okay. Alkaline earth metals. Okay. So we have the alkali metals and the alkaline earth metals. I got to tell you guys, it's extremely difficult keeping those straight. Do your best. I'm not going to be super snippety about it. Okay. The alkaline earth metals, they are in group 2. So how many electrons do you think they have in their valence shell?
2.
2. How many electrons does group 1 have in their valence shell? 1. Group 2 has 2. You guys seeing the trend here?
Yeah.
Okay, so they have 2 electrons in their outer valence shell. Do you think they are happy with that?
No.
They are not. They are not happy unless they have a full outer shell. So do you think that they are going to try to get electrons or give them away?
Yes.
They're going to give them away because it's only 2 of them, right? Here, have 2 electrons. I don't need 2 electrons. So they are also silvery. They are also solid. They are also reactive. They are not quite as reactive as group 1 because it's harder to get rid of 2 electrons than it is to get rid of 1. Like beryllium there, when it gives away 2 electrons, that's half of its electrons. That's kind of a big deal, right? Like that's like, it's still going to do it, but it's not going to do it super cheerfully. Does that make sense? These elements are silver colored and they're solid. They're reactive with water, but less so. They're not quite as reactive because, like I said, getting rid of two electrons is a little bit bigger of a deal. They're not going to be like, woo, take my electrons. Okay. They each have 2 valence electrons that they would really like to get rid of. So calcium has a 2+. Calcium will get rid of them. Magnesium will get rid of them. Beryllium will get rid of them. Okay. Go ahead, Gabe. So they will readily bond with other elements. They will give away their 2 electrons, but by so doing, they form a bond. That is how molecules and atoms, that's how molecules are formed. is by the sharing and the giving of electrons. So Gabe, yesterday you asked, what if electrons didn't have a charge? They wouldn't get rid of them and they wouldn't care, and we wouldn't have any molecules, we'd only have atoms. Boring, because there's not a lot you can do with just a bunch of molecules. Have to have a charge in order for life to happen. Yeah, it really is. So they transfer their 2 valence electrons to become stable ions with full outer orbitals. So they're ions because they're charged. Every kid, not every kid, it is very, very, very common to confuse isotope and ion because they both start with the letter I. Remember, iso means the same. Ion, I don't have anything for you to remember that. But if you remember that iso means the same, it'll help you in science for the rest of your life. Isobaric means it happens at a constant pressure. Isochoric means it happens at a constant volume. There's one that happens at a constant temperature, and that name has left me. It's probably the most easy one, and I don't remember. So elephants. Elements get, what do you think? They get more reactive as you go up or down?
Down.
Down to the group. Why?
Because they get
Because
more.
the babies at the back.
Because they have more electrons.
They have more electrons, so they don't care as much, right? Like Chad, if you have a pile of 60 gumballs and somebody asks you for 2 gumballs, are you gonna care? No. If you only have 4 gumballs, are you maybe gonna care? Yeah. Well,
It depends if it's my sibling asking.
Yeah,
Yeah.
my friend. Good point.
you're still gonna not care as much. Or let's
Counting them beforehand.
Yeah.
no, you're not gonna notice. You're not. If you have 4 gumballs,
If like notice more if 2 were missing out of my 60 than if 2 were missing out of my 4, because I must have been like, oh, I must have ate them or something.
no, I'd noticed if I had 2 missing out of my 4. We had a home health nurse who would help take care of my son because he was on a ventilator while he sleeps. And she was stealing medicine. And when we had 12 and she stole 6, yeah, I noticed. But I didn't notice when we had like 24 and she stole like 2 or 3. Right?
Well, but like with your chickens, like you wouldn't really notice if you had 60 chickens. And
If I
you
had
would-
60 chickens and the fox comes and takes 2 or 3, I'm gonna be like, oh crap. When I lost 8 chickens out of my 14 in one night, yeah, I noticed. No, like the fox comes and takes the chickens and runs away. There isn't even feathers all over the ground. But the fox is no more in there. The fox is now a lovely fur, whatever the trapper did with them.
The foxes.
Yes, there was more than one.
There are foxes. The foxes are dead. Ding dong. The foxes are dead. Okay. So the elements get more reactive as you go down the group. Okay? Because they miss those electrons less. So there's radium is the most reactive. It is also radioactive. Radium is a radioactive element. It was discovered by the Curies, Pierre and Marie Curie.
Wait, isn't it a gas?
Radium is not a gas. All of the alkaline earth metals is over here. Radon's a gas, but all of these guys in these families are going to be solid. All of them are going to be solid. Yeah. Marie Curie
Here,
Yeah.
and Pierre.
here, and Andre Louis you're buying.
Yeah. But the Curies get credit for it. He was their lab assistant.
Yeah.
And they got the Nobel Prize for it. Yes, they did. All right, so we're gonna put 2 on these. Ignore the tens place, okay? We're gonna, how many valence electrons do you think boron has? 3. How many valence electrons does carbon have? 4. How many valence electrons does fluorine have?
7.
7. Okay. What do you think fluorine wants more than anything else in its entire universe? It wants 1 more electron, so stinking bad. Fluorine is the absolute most reactive element on this thing. It wants an electron so bad. It will do anything to get an electron. It has been known to strip electrons off of some of the noble gases, which does not happen, but fluorine can do it, right? Like fluorine wants an electron so bad. These are called the halogens. Have any of you ever heard of a halogen lamp?
Yeah.
Halogen lamps have halogen gas inside them, and that's how they go. So chlorine, fluorine, iodine, those are all toxic things. Okay. So chlorine gas is toxic. Fluorine can be toxic unless it's bonded as fluoride, and then you put it in your teeth and it builds up the bone structure of your teeth or the mineral structure of your teeth. How cool is that? So, but they are also very, very reactive. So if fluorine, chlorine, bromine, iodine, and astatine really, really want an electron, and hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium really, really want to get rid of an electron,
Become best friends.
they become best friends, and they're best friends a lot, right? So they're all non-metals. So if they're non-metals, are they a gas or are they a solid?
Yeah.
They're gas. Sometimes you'll find them as a liquid, but they're usually a gas. And they are found in all 3 states of matter, but usually you'll find them as a gas.
Oh, for a minute I was like, all 3 states. There's
All 3 states. There's 50 states.
yeah, I was
But you'll only find them in Texas, in Colorado, and in New Hampshire. Those are the only.
Why so like different though? Like Colorado, Texas, and then
Because
New Hampshire.
those are the ones I thought of first.
you didn't think of Idaho?
But it's not like they're right next to each other. It's just like only in Texas, not on the border,
Right, not
in
in
New
Oklahoma,
Mexico.
just in Texas. Oh, because I'm full of crap. Yes.
About the 5 states. Because there's 5.
Okay, but in normal atmospheric temperature and pressures, there's only 3. So those are the ones we're going to be focusing on that happen in normal atmospheric temperature and pressure. We know that there's plasma and we know that there's Bose-Einstein condensate, but those don't happen in our normal everyday life, right? You're not going to be going along and go, oh crap, there's some plasma. It's not going to happen. Yeah.
Fire.
Fire. Doesn't happen.
You better go the other way.
Actually, no, that's the thing. If you're running, oh, there's lightning. Yep, actually do go the other way.
No, but you don't see a lightning.
And
bolt
also,
and be like,
if you're trotting along, oh, there's fire. Yeah, actually do go the other way. Actually. The fluorine and chlorine are usually gas. Bromine's usually liquid. Iodine and astatine are usually solid.
What about solar flares?
Okay, those aren't on Earth. They are the most reactive of the non-metals. Because why?
Because they really, really want it.
They have 7 valence electrons. Guys, they want an electron so bad they can hardly stand it. They just, I mean, like, oh my gosh, they're like, I need an electron, I need an electron. Like, seriously. They're one electron short of a full outer shell. There's another one, like when you encounter a stupid person, you can say, he's 1 electron short of a full valence shell, and you will sound so smart. So they readily combine with other elements to take 1 valence electron. So do you think that they would combine with any of the alkaline earth metals?
No.
no.
No, but 2 of them might. So let's say you have calcium. Calcium can give 1 electron to 1 fluorine, and one electron to another fluorine, and they've got a little trio now, right?
Double trouble.
So that stuff happens. But
Double
calcium is not going to be really happy giving away just one of its electrons, because calcium's going to be like, now I only have one. That's even worse. Like, I'm worse. But calcium can give one to one fluorine, one to another fluorine, and then you have CaFl2, which happens, right? So you kind of have to think of it that way. They don't just bond one-on-one. You can have atoms and molecules, or you can have molecules with lots and lots and lots of atoms in them. So NaCl is one of our favorites. It's extremely common. Sodium chloride happens all over in nature, and I like it, and we need it for our bodies. It tastes good. It tastes good because we need it for our bodies. Like we have a salt lake out back for our cows because you will die without salt. Halogens become more reactive. What do you think as you go up or down?
Down.
Okay, so Brooklyn, why do you think you said wait? Okay, so who says down? Because Brooklyn just changed her mind.
Yeah.
Why? Okay, Brooklyn, why did you think down, and why did you change your mind?
Because I was thinking down because that's how the other ones go, but then I was thinking up because fluorine's the most reactive of them.
Ooh, okay, you're listening to what I said. Why would fluorine be the most reactive? Jaden, what do you think?
Oh, I know, because so originally they didn't want to give away an electron because that's like half of it. But these ones, they have less. They also have less electrons the higher up. But getting another electron contributes a lot more to them than the lower ones. So the higher ones would be more reactive.
Okay, what do you think, Brooklyn? Or a brief?
Don't want, like, they want to give it these ones, they want them so bad because they only have none, and they're like, I need one more. And then the like astatine or whatever,
Right.
it's like, I want one, but I don't need it so bad because I already have so many.
That's exactly right. So they have a lot. They're like, okay, one more would be really nice because I'd really love to have a full outer shell, but I have a lot. It's like if you already have 60 gumballs, do you really need one more? I mean, really?
Yes.
You have, you do. You do need one more gumball because you want all the gumballs. But it doesn't matter as much. It's not as great as a percentage. So yes, as you move up the group, they become more reactive. Fluorine is extremely reactive. So we've got chlorine, bromine, we've got things there. Iodine is a great, people call it iodine. I call it iodine just because it rhymes with all the others. But it's a great at killing germs because it's pretty toxic. Don't drink it. Chlorine is the most reactive. Hydrofluoric acid is an extremely dangerous acid. It has anesthetic properties. It will numb you while it penetrates into you and bonds. It wants to bond with things so badly that the fluorine will go in and it'll start bonding with the calcium in your bones, and it will destroy your bones. Yeah, I'm going to wreak some havoc. There's a professor at the University of Utah who spilled 2 drops of hot hydrofluoric acid on his finger, and he ended up having to have several. It's probably you.
Can I please get Nicole Trahant to come to the office?
Okay, not you.
Nicole Trahant?
Yes.
Oh, I didn't ask if that's like what it was.
Yeah.
Like,
So the halogens are very reactive, but then we have
noble gas.
the noble gases. All right, those of you who are doing noble gases in your baby books, what compounds are made with them?
Wait, what?
Noble gas baby book people. Helium, neon, argon, krypton, xenon, and
Right.
radon. What compounds are made with those? What are they going to be when they grow up?
Lasers.
Do they form any compounds?
Mine will xenon.
Xenon, are there any compounds that are formed with xenon?
I don't know.
You haven't gotten there that far.
Yeah.
How many valence electrons do they have? 8, because they're in group 18, and we knock off the ones who were there in group 8.
Oh, so they don't want any.
Yeah, they don't.
They have a full valence shell. they're so happy. They're like, don't touch me. You can't have one of my electrons. I don't want one of your electrons. They do not bond with anything. They just, that's why they're a gas, is they don't form compounds. They don't form solids. They don't form liquids. They just kind of float around by themselves. Yes.
So is that where the like helium?
You know, hydrogen and oxygen bond to form water. They're there together, but they're not like messing with each other. Yes.
What if we have like fluorine touch like an atom of helium and lithium gave one to the helium?
Helium's not giving it up.
Does that-
Occasionally, fluorine will take an electron, like from xenon, because xenon has so many, it's not going to notice so much. But that is actually really pretty rare. That's Olivia.
Can I please get Olivia Tivo to come to the office? Olivia.
So,
Tivo.
and that's extremely rare, and that's only because fluorine really, really wants that electron, and xenon's really, really big, and it's not going to notice that much. These guys are called the noble gases because nobility, back in the days when they had kings and queens and stuff, did not associate with the commoners. They don't associate with electrons. They're not going to react at all. They're completely unreactive. You're not going to have any chemical reactions involving any noble gases. Helium's just going to be helium forever. Yes.
So if fluorine does take one from xenon, why can't something like lithium come and form a 3-part bond?
It would last. It's not going to give that up very readily. Yeah.
So what kind of compound would it even create?
I don't even know. Like, I don't even know. We could maybe look this up and see if it's happened, but I don't even know. Really, 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 for the most part, do not form molecules. They are non-reactive gases. They do shine pretty colors when you send electricity through them. There's neon, and helium makes great balloons, right? They do not bond. They are snobbish, snobby snobs, and they don't want to bond. They don't want to have friends. They're that kid over there sitting in the corner. They don't want to. Just don't touch me, right? Don't touch it. Yes, Gabe.
I found a ton and they all end with like fluorine.
What?
They all end with like fluorine.
Yeah, because fluorine is the only one that has the power to pull an electron off. They have full outer orbitals. They're happy. Now, helium only has 2, right? But it's still a full outer orbital. And then the others all have 8. They do not form compounds. They do not form molecules. They just don't. Noble gases are also described as inert gases. They just don't react, right? It's like the soldiers outside of Buckingham Palace, and you try to poke them and they just don't move. Those are the noble gases. They just don't
break.
They don't do anything, okay? So these are the ones that you need to have colored in, okay? So we've got alkaline metals, alkaline earth metals, noble gases, and halogens. Here we have groups 3 through 12. We will not be dealing with these very much in this class.
Those are transition metals.
Those are the transition metals, okay? We're not going to talk about them super much. They contain metals that have, they're normal metals. They're copper and they're iron and they're, nickel, and their electron structure is really more unique. It's not as tightly bonded to the atom, and the electrons are kind of more free flowing like a soup. And that's why they conduct electricity so readily, is because they don't really have the shells. I mean, they kind of have the shells, but that valence shell is more soupy, and they kind of share the electrons. So they're always found in the solid state, except for what?
Mercury.
Mercury. Don't play with mercury. Like, really, really don't. Like, it will either make you really stupid because it will give you brain damage, or it will kill you. Same with lead. The transitions metals contain some of the most commonly known metals.
Iron.
Okay, what's this made from? What's that one made from, do you think?
Silver.
Probably
Silver.
silver. Ooh, that, you know, it was a good guess. What's that?
Copper.
Copper. Ooh,
Gold.
copper
Copper.
penny.
Wow.
Oh, the pen.
There's a
Stainless
Iron.
steel.
cast iron pen. What's that one? What's the filament in a light bulb? Tungsten.
Yes, for the win.
Airplanes are made from
From-
titanium because it's really strong and really light. Interesting though, so is beryllium. Anyway, gold jewelry, silver goblet, mercury. You're not going to find a lot of mercury thermometers. They're just so dangerous, and they're so terrible for the environment. Like you break a mercury thermometer and you send it to the landfill, and now you have mercury in your water because it rains in the landfill and it goes down into the groundwater, and then you drink the mercury, and now we have mercury poisoning. So the lanthanides, they are all metals that have been called rare earth metals in the past. Now we call them lanthanides. We're not doing anything with them in this class. And the actinides, they are also metals that are all radioactive, every single one. We're not doing much with them in this class. They will spontaneously combust in the air though, so that's kind of fun. And they're radioactive. So, electronegativity, how desperately an atom wants electrons. As we go right on the periodic table, do you think electronegativity goes up or down?
Down.
It's how bad they want an electron. Now, if we're ignoring the noble gases aren't part of this. So we're talking about everybody but the noble gases. Noble gases don't want an electron. So we're going to end with fluorine and francium, and we're going to have francium and hydrogen.
Oh, wait,
Okay.
go up.
To go up.
The I did it backwards. And then it goes down as you go down. So the one on the lower left has the lowest electronegativity, that's francium. The one with the highest electronegativity is fluorine. So francium really, really, really doesn't want extra electrons, and fluorine really, really, really does. Is the more reactive it's going to be. So francium is highly reactive and fluorine is highly reactive. The only reason we don't have more francium compounds is because it's radioactive and it kind of disappears. So then we have atomic radius. Now kind of something interesting happens with atomic radius. Now, the easy one is as the atomic radius goes down, as we go down the periodic table, do you think atomic radius is going to go up or down?
Up.
Why?
Because there's more numbers.
Because there's more electron shells, right? Like you put another box on the outside of your birthday present, you're going to get a bigger box, right? Like it's not going to get smaller. Like that doesn't even, like that hurts my brain.
I mean, unless you like destroy the box and put it in a smaller box.
Like, yeah, that doesn't even work. So as we go down, oh crap, spoilers. As we go down,
no.
it increases. But as we go to the right, even though we are adding on electrons, it decreases. Why do you think? Why do you think it would decrease? Why would they get smaller as it goes to the right, even though we're adding on electrons? Kind of hurts my brain. Like what? What's going on?
Opposite of what I'm about to say.
It's not getting more shells. Fluorine has the same number of shells as lithium. But fluorine is smaller than lithium. But fluorine has 7 electrons in its shell, and lithium only has 1. What's going on? There's 7 electrons. Why is it bigger than if it has 3? Because physics is not broken, and it's actually because physics isn't broken, that's why. How many protons are holding on to those electrons in fluorine? How many protons does fluorine have?
9.
9. And they're really pretty close because there's only 2 shells, right? Are those protons going to have a good tight hold on those electrons? How many protons are holding on to the electrons with lithium?
3.
3. That's not a lot of protons. That's not a lot of charge to be able to hold it on. It's kind of like, think of it like Jupiter. Jupiter has more mass than the Earth, right? So Jupiter has more gravity. So if we were on Jupiter, we would weigh more and be stuck more tightly. We wouldn't even be able to jump as high, right? Force from those protons is holding on tighter. Fluorine is also extremely electronegative. So we really tightly. Fluorine is the smallest. I mean, like hydrogen is a smaller atom, but on this row, fluorine is the smallest. Well, no, neon is going to be the smallest because they're holding on so tight. To their atoms. And of course, as you go down, you get more shells, so they're going to be bigger. So like like radon is going to be smaller than cesium, even though there are electrons in radon. Radon's holding on, and they're more electronegative, so they're more motivated to keep those electrons on. Think of like a dragon, like holding on to his cord, and he's just, or like a little kid with candy, and they're just not even going to let go, right? Or you with candy, and you're not going to let go. A big kid. With candy increases. Do you have any questions? Sophie, do you have questions?
No, I'm good.
Bree has a question.
So what's the group called with like aluminum, gallium, indium, thallium?
That's all kind of one big group of metals. They're all just one big family, and it's just interesting. But we don't really have. We have names for group 1, 2,
3 through 12.
kind of 3 through 12, and then 7 and 8. And like you have the transition metals. They're kind
What
of
about, like,
all lumped together. Isn't that weird? It's weird. But they're kind of grouped more like by chemical properties. The ones at the beginning are nice in a row, and the ones at the end are nice in a row, and then the other ones are kind of a little bit more mushy because they have similar properties. Any other questions? Okay, so I am turn this in just so I see that you did it. If you want another one, like if you messed up and you want to make it pretty, you can. But then I'm going to hand it back. Guys, this, can I borrow yours? Because yours is, this is going to be a very, very, very valuable tool. I hole punched it for you. When I hand this back, keep it, keep it, keep it, keep it safe. Maybe even put some tape around the holes, because this is going to be a good reference material for you for the rest of the quarter term. Okay, this periodic table is now your best friend. I suggest you bond with it. Maybe share some electrons. So I do want to make sure you got them labeled. If you need help labeling things, I can help you if you weren't able to keep up. And I do have a little assignment, kind of a making sure you're paying attention thing. It's not really a big deal. If you're paying attention at all, you'll be fine. Okay. And if you have something on there that you're like, this is Barlow, I cannot. You just ask me and I'll help you. Right. So Sophie, I think we're gonna sign off. You good?
Yeah, I'm good.
phone in the working or something, or your computer or something.
I like Sophie, but she'll actually respond. Okay, stop. We're gonna
And
stop sharing. Bye, Sophie.